Hi guys, it's Mr. Zimmerman, and today we're going to look at the last section in Chapter 3, which is on solving absolute value inequalities. If you remember back from Chapter 2, when we solved absolute value equations, we had to make two equations, or we had to make two cases. And when we did that, after we got the first thing we had to do was get the absolute value all by itself. And then we had to set up our two cases where the second case, we had to change the sign on the number on the right-hand side of the equation to negative. So we're still going to set up two cases solving absolute value inequalities. And now we have to change the sign to negative. And we also have to flip the inequality symbol. So when we get in the examples, I'll show you exactly how this works. But there's a couple notes that I want to make on the bottom of this page. So again, the first step will always be to get the absolute value all by itself on one side of the inequality. But then, very important, it's going to be important that you note that if it's a less than after you get the absolute value all by itself, then that's going to tell you that this problem is a AND problem, which we also knew that was also, we said that was the intersection. And when we were shading our number lines, that was the double shaded part. Okay, so that's very important. And then over here to the right, again, we're going to try to get the absolute value all by itself. And then after we do that, if it's a greater than, then this is going to be an OR problem, which, remember, that was called the union. And also, do you remember I said that when it was a union or an OR, we're looking on the number line for anywhere that is shaded. So those are very important points for this section. All right, let's take a look at some of the examples. So let's turn the page and look at example 1. So the first thing we always have to do is get the absolute value symbol all by itself. So in this case, we're going to add 3 on both sides. So that's going to give us the absolute value of x. The 3's are going to cancel here on the left-hand side, bring down our inequality, and we have on the right-hand side negative 1 plus 3, which is 2. All right, now that we have the absolute value all by itself, the next thing we want to note is that this problem is a less than. So now that when the absolute value is all by itself and we have a less than, we know that this problem is going to be an AND problem, or an intersection. Now let's break it down into our two cases. Our first case, we drop the absolute value symbol and we leave the inequality as it was, and we have x is less than 2. And we have put that word in here. In the second case, we take the x out of the absolute value. We have to flip the inequality the other direction, so now it's a greater than, and we have to take the negative of that number on the right-hand side, so it'll be a negative 2. Now let's graph this on our number line. Let's do the first inequality here in red. So we're going to put 2 on our number line, and we have an open circle shaded to the left. And then our second inequality, let's do this one in green. We're going to put negative 2 on our number line. Again, that's an open circle, and this time it is shaded to the right. Well, again, what we're looking for now is we're looking for the overlap. When it's an and, we're looking for the double shaded part, which would be this intersection right in there. And so we already went over how do we write our final answer then in that case. Well, we would know that it's all the x's, all the real numbers x between -2 and 2. So let's put x between -2 and 2. And then we will put a less than symbol and a less than symbol. And there you go. There's our solution for number 1. In number 2, the absolute value is already by itself. But again, we want to note that this problem contains a less than. And again, it happens to be a less than or equal to, but it's still a less than. So we want to remind ourselves that after we have the absolute value by itself, we want to look at that inequality symbol. And since it's a less than, this problem is an and. So we're going to be looking for the intersection or the double shaded part. So let's go ahead and break this down into our 2 cases. So the first case, we take the quantity x minus 1 out of the absolute value. And we keep our inequality symbol as a less than or equal to, and we put our 2 on the right-hand side. And then we take the quantity x minus 1 out of the absolute value again. We flip the inequality to a greater than or equal to, and we take the negative of that number on the right-hand side. Now we just need to solve both of these. All right, so to solve the inequality on the left, we're going to add 1 on both sides, and that's going to give us x is less than or equal to 3. And the inequality on the right, we add 1 on both sides, and we get x is greater than or equal to -2 plus 1 is -1. Now we're going to graph both of these on our number line. So let's do the first one here in red again. So we're going to put 3 on our number line. This time we do have an equal to bar, so it's going to be a solid dot at 3. And we're going to shade it to the left. And then let's do our second inequality in green again. So we'll put -1 on our number line. And then again, we have the equal to bar, so we have a solid dot. And this one is shaded to the right. Then our solution again, we're looking for, since it's an and, we're looking for the intersection. We're looking for the part that's double shaded. So we want the part that's shaded both red and green at the same time. You can see that that's all the numbers x, all the real numbers x in between -1 and 3. But then we'll also want to include the -1 and 3 as part of our solution, since those are solid circles at -1 and 3. So let's write our final answer for this one. So again, we want the x's. We want them to be between -1 and 3. And we're going to make a less than. But then since we have solid dots, we're also going to include the equal to bar at -1 and at 3. So there's our solution for number 2. Let's move on to number 3. For number 3, the first thing we need to do is get the absolute value all by itself. So we are going to subtract 14 on both sides. Then we have the absolute value of x is greater than or equal to 19 minus 14 is 5. Now that we have the absolute value by itself, we want to take a look at this inequality symbol right here. And we want to remind ourselves, since it's got a greater than in it, even though it's a greater than or equal to, that this problem is going to be an or problem. So we're going to be looking for the union or anywhere that is shaded on our number line. So let's go ahead now and set up our 2 cases. So our first case, we take the x out of the absolute value, and we leave the inequality symbol as a greater than or equal to, and our right-hand side is 5 on that inequality. And then we put the word or in between. Then we take the x out of the absolute value again. We have to flip the inequality to a less than or equal to and take the negative of that number on the right-hand side. So it's going to be a -5. Well, if you look at these are already solved, okay? So let's just go ahead and graph them. So the first one we're going to do in red here. So we want to be greater than or equal to 5. So let's put 5 on our number line. And we have a solid dot because of the equal to bar. And we shade to the right. And then the other one we'll do in green again. So let's put -5 on our number line. That's also got the equal to bar, so we have a solid dot. And we are going to shade to the left. All right. So in that case, just like in section 3-6, we really have our solution written already. We have two separate sets that have this gap in between right here. So how we write that, again, we're looking for an or. We're looking for the union or anywhere that's shaded. Well, to describe anywhere that's shaded, it could be shaded red, or it could be shaded green, or it could be shaded both. But just anywhere that's shaded on our number line. So we have really written our solution already, but I'll rewrite it so that I can circle it for you guys. So our final answer for this one is just x is greater than or equal to 5, or x is less than or equal to -5. Let's move on to example 4. So in example 4, the first thing we're going to do is get the absolute value all by itself. So we need to subtract 3 on both sides. The 3's cancel out over here. And on the left-hand side, we now have the absolute value of the quantity x plus 2. And that's going to be greater than 5 minus 3 is 2. So now that we have our absolute value all by itself, again, we want to note that this is a greater than. So we want to remind ourselves that that is a or. That is an union. So we're going to be looking for anywhere that's shaded on our number line. So now let's break it down into our two cases. So our first case, we're going to take the quantity x plus 2 out of the absolute value and set it greater than 2. And then or, we're going to take the quantity x plus 2 out of the absolute value symbol again. We're going to flip the inequality to a less than, and the right-hand side will now be -2. Now we just have to solve both of these. So on the left inequality, we're going to subtract 2 on both sides, and we're going to get x is greater than 0, or on the right inequality, we're going to subtract 2 on both sides, and we're going to get x is less than -2, take away 2 more is -4. All right, let's graph these. So the inequality on the left, we're going to do this one in red. So x is greater than 0, so let's put 0 on our number line. There is no equal to bar, so this is an open circle at 0, shaded to the right. And then the other inequality we have, we'll do in green. So then this one, we'll put -4 on our number line. So here's -4. There's no equal to bar on that inequality, so that's also an open circle, but this one is shaded to the left. So again, since our problem is an or problem, we're looking for our solution to be anywhere that's shaded on our number line. And again, we have these two separate disjoint sets with this gap in the middle. So the part that's shaded in is the part that's green, or the part that's red. So then we really have our solution written out again, but I'll write it for you guys again. So our final solution is x is greater than 0, or x is less than -4. Let's move on to number 5. On number 5, we've got to get the absolute value all by itself first, so we're going to add 5 on both sides. And that's going to give me the absolute value of the quantity x plus 4 is greater than -8 plus 5, that's -3. All right, so then this one, you want to note that this is a greater than again. You don't check that until you get the absolute value all by itself. So it's a greater than, so then we know that this problem is an or problem. So then we're going to break it down into our two cases. So the first case, we take the x plus 4 out of the absolute value, and we set it greater than -3, or Then we take the quantity x plus 4 out of the absolute value again to get our second case. We flip the inequality the other way, which is less than, and we take the negative of that number on the right-hand side. Now let's solve each of our cases. So in the inequality on the left, we're going to subtract 4 on both sides, and we get x is greater than negative 3, take away 4 more is negative 7. Or on the other inequality on the right here, we're going to subtract 4 on both sides, and we get x is less than 3, take away 4 is negative 1. Now let's go ahead and graph this one. So in red again, we'll do this one on the left. So we got x is greater than negative 7. So let's put negative 7 on our number line. We have an open circle at negative 7, and that would be shaded to the right. Now our inequality on the right, let's do this one in green again. So let's put negative 1 on our number line. Again, making sure you have negative 7 and negative 1, they don't have to be the scale, but they have to be in order left to right on your number line. So let's put negative 1 right here. Again, there's no equal to bar on that one, so we're going to make an open circle at negative 1. And this is the x's less than negative 1, or to the left of negative 1. So we shade this one to the left. Now, this is an OR problem. Okay, in an OR problem, remember, we're looking for the union, or we're looking for anywhere that's shaded. It could be shaded green, it could be shaded red, or it could be shaded both colors. Well, if you look very carefully at this one, the entire number line is shaded in. Again, this entire number line is shaded in. This part to the right of negative 1 is shaded red. This part to the left of negative 7 is shaded green. And then this part in the middle is double shaded. But the entire thing, remember, an or a union is anywhere that is shaded. Well, since the entire number line is shaded in, then our answer for this one is all real numbers. So I'm going to write this symbol right here for all real numbers. All right, that means any number that you pick for x, any real number, will make this original inequality true. Now, there was a point where you may have seen that when you got this absolute value. Look at this step right here, when you got the absolute value all by itself. Well, look at what that says. We know the absolute value is always positive, right? So this is always positive, the left-hand side. Well, that's always going to be greater than a negative number. So right there, we could have realized that the answer was all real numbers. But again, I don't want you to jump into those kind of conclusions. So if you just follow the process and work it out, as long as you remember that the OR is anywhere that it's shaded. As long as you keep that in mind, the problem will work out correctly. Let's look at number 6. So again, the first step is to get the absolute value all by itself. So we are going to subtract 9 on both sides. That gives us the absolute value of the quantity x minus 2 is less than 7. Take away 9 is negative 2. Now let's go ahead and set up our two cases. The first thing we want to do on this one, though, again, is we want to note that since this is a less than right here, this problem is an and. Again, the and, that is the intersection, or we'll be looking for the double shaded part on the number line. Again, you don't determine that it's an and or an or until you have the absolute value all by itself first. That's when you look at this inequality symbol and decide whether it's an or an and. Okay, well, let's break this down into our two cases then. So our first case, we take the quantity x minus 2 out of the absolute value and we set it less than negative 2. And then we take the quantity x minus 2 out of the absolute value again and we set it, well, we have to flip the inequality to a greater than, and we take the negative of that number on the right-hand side, which would be a positive 2. Now let's solve both of these. So we're going to add 2 on both sides. And our inequality on the left now becomes x is less than, well, negative 2 plus 2, that is 0. And we'll solve our inequality on the right, so we'll add 2 on both sides. And for this one, we'll get x is greater than 2 plus 2, that is 4. So I wrote you a little note here. Again, this problem is an and, so that is an intersection, or we're looking for the overlap, which I've been calling the double shaded part. So we're going to look for the double shaded part on this number line. So keep that in mind. So again, graphing the inequality on the left, we'll do that one in red. So we got x is less than 0. So let's put 0 on our number line here. There's no equal to bar, so it's an open circle, and that is shaded to the left. And then in green, let's look at this inequality on the right here and graph that one. So let's put 4 on our number line. And again, that one, there's no equal to bar, so that's an open circle, and that one's shaded to the right. Well, look at this one. We're looking for, well, again, the problem is an and, so we are looking for the double shaded part. So we're looking for the part that's shaded both red and green at the same time. And if you look at this, there isn't any part that's double shaded. Well, that means there is no solution. So the answer for this one is no solution. So no solution. And when you write, if you want to write no solution, you can also make that symbol right there. So either way. Well, this one you might have been able to tell earlier on this one also that there was no solution. If you look back to the point where you got the absolute value all by itself, which was this step right here. If you look at that, well, on the left-hand side, you know the absolute value is always positive, right? So can something that's always positive be less than a negative number? No, that can't happen. So right there, you could have realized there was no solution. But again, I don't like you guys to jump to conclusions because sometimes you make mistakes and you think there's no solution to the problem when there really is. So if you go ahead and follow the process, same process we used on all 6 examples, you'll get down here to the end and you'll realize that you're looking for the double shaded part, and there is not a double shaded part, so there is no solution. All right, one more to go. Let's look at the last example. This last example is our story problem for section 3-7. And what it says is that a pediatrician recommends that the baby's bathwater to be should be 95 degrees. But it's acceptable for that temperature to vary by at most 3 degrees. Well, that means the temperature could be 3 degrees above 95, or it could be 3 degrees below 95. So we're supposed to write and solve absolute value inequality for this problem. The first thing I want to note on this one is that at most, right here, that means less than or equal to 3 degrees. Okay? So let's let X represent the actual temperature of the water. And then the recommended temperature is 95 degrees. And we want the difference between these two temperatures to be no more than, or at most, 3 degrees. So that's got to be less than or equal to 3 degrees. Well, I think you guys can see that if you solve this right now, you would add 95 to both sides, and that would give you the upper value for this range of temperatures, which should be 98 degrees. But the only way you're going to pick up, we also said that the temperature of the water could be 3 degrees less than 95. Well, the only way you're going to pick up that other part of the solution is if you put the absolute value into this problem. So let's go ahead and solve this. So right now, we're looking at this problem. We already have the absolute value. Well, again, our first step is always get the absolute value by itself. So we've already done that. So the next step is on an absolute value inequality is we have to look at this inequality symbol, and we see that it has a less than in there, so we know that this problem is going to be an and, which means we're looking for the intersection or the double shaded part. So then let's go ahead and now we have the absolute value by itself. Let's set up our two cases. So the first case, we're going to take the quantity x minus 95 and set it less than or equal to 3. And we're going to set up our second case, which is we take the quantity x minus 95 out of the absolute value again. We flip the inequality to a greater than or equal to, and we take the negative of that number on the right-hand side. Now we just need to solve both of these. So if we add 95 on both sides, I think you can see that we have x is less than or equal to 3 plus 95, that is 98. And we solve the inequality on the right-hand side. So again, we add 95 on both sides. And this one, we get x is greater than or equal to negative 3 plus 95. That's going to be 92 degrees. Now let's talk about our number line on this one, since they didn't draw one for us, but we should really do this. So if we draw our number line on this one, we only need to put two numbers on our number line. So again, we are going to do this inequality on the left. We'll do this one in red. So we're going to put 98 degrees on here. This one does have the equal to bar, so we're going to make a solid dot. And that one is shaded to the left. And then same thing like all the other problems, we're going to do this inequality on the right in green. So we're going to put 92 on our number line. Well, that would go to the left of 98. So here's 92 on our number line. That one has the equal to bar, so we're going to make the solid circle. And this one, the x's are greater than or equal to 92, so this one we're going to shade to the right. All right, well, again, we're looking for intersection, right? We have the word and here, which is the intersection, which is the double shaded part. So we're looking for the part in here that is double shaded. It is both red and green. So then we know how to write those answers. So we will say we want all the temperatures X. We want those to be between 92 and 98 degrees. And we're going to put a less than, and we have solid dots on at 92 and at 98, so we'll put the equal to bars in there, and then that is our solution. So that means it's acceptable for the temperature of the water to be between 92 and 98 degrees, and because of the equal to bars, it could also be 92. It could be equal to 92 or equal to 98. All right, well, that does it for Chapter 3. So again, thanks for watching, and I'll see you in class. Bye.